Alrighty, Econ students, we're talking about factor markets here. And this already says perfect competition here at the top. We've talked about this in class, and we've seen that the MRP functions as your demand curve. As I lower the price that you'd be willing to pay, or I'm sorry, as I lower the wage from $13.95 to $11.95 to $9.95 to $7.95, you're looking at the MRP column to see the quantity that you demand. So your demand curve is your marginal revenue product, okay? So far, so good. What we need to talk more about is what if you were an imperfect competitor, okay? But before we do that, let's look at the product and factor markets and see that they are related. In perfect competition, you have tons of firms, so you're a price taker. It also means you're all competing for the same resources, so you're a wage taker. And so here you look, we've got the market. The demand curve is the sum of all the firms' MRPs. At a high wage, firms don't want to hire many people. At a low wage, they do want to hire a lot of people. At a high wage, lots of workers want to work. At a low wage, very few want to work, and we meet at equilibrium. How this works is that your equilibrium wage becomes a perfectly elastic supply curve, and you would hire this quantity. Good trade, good trade, good trade, good trade, good trade, stop. Right? Bad trades to the right of Q, and that's taking the equilibrium price or wage and quantity. Now, what we haven't talked about is, what if you were an imperfect competitor? What does your demand curve look like? Your MRP is going to fall faster or be more inelastic because now you have diminishing marginal returns and the product price is falling as output increases. You have the law of demand impacting your price in a way that it wasn't before because you were a wage taker in the previous scenario. So when you do this, how would you know that this is imperfect competition? Look at the product price. And here, as you lower from 280 to 260, the total produced increases by 7. At 240, right, your marginal product goes to 6. At 220, your marginal product is 5. But you can no longer do MP times MR to get MRP. And the reason is that MR is changing. So we don't do this any longer. The only way to get MRP is the change in the total revenue over the change in the quantity of workers. So why is an MRP of the second worker 6 times 1440? Because the previous 7 units were being sold for 20 cents more. You're losing $1.40 on what would have been sold at a higher price. So if you take 1440 minus that $1.40, which was 7 times 2, 7 times 0.2, you get 13 bucks. And that's exactly what we find for the MRP, okay? So this is from your book. It's not elegant, but this would be pure competition. This is imperfect competition. As you can see, you just have a steeper demand curve. Now, what are the shifters? We talked about this briefly today. Product demand, productivity, and the price of other resources, right? I tried to keep them the same. With substitutes and complements, what we're talking about when we say substitutes and complements is labor and capital. Okay? And sometimes capital gets substituted with just a K, right, for simplicity. So let's look at the shifters. Ceteris paribus, more productivity is going to be more demand, and less productivity is less demand. More productive workers come through technology and education. And remember before, if we did MP times MR equals MRP, if we're increasing productivity, you could just say 10 times 10, the MRP of the worker is 100. Well, what if their productivity doubles? What just happened to their MRP? It doubled, right? And if you even picture that on a graph, if the MRP is doubling, that's this demand curve shifting to the right, okay? So productivity is a huge shifter in the demand for labor. We'll talk more about that in a minute. This is what I was just saying. What happens to MRP if MR doubles? If MP doubles? This is the price of the product, right? So again, say your worker can produce 10 units and you can sell them for $10 each. The MRP of the worker is 100. But what if the price of the product, there's increasing demand for the product, and all of a sudden you can sell each of those for $20 each? Well, now the MRP of your worker has doubled as well. Okay? We did this problem in class. You can check it out from 2007. It's just proving again. Actually, we'll go back and show this. It's proving again that if the labor productivity doubled, you'd have a shift in demand to the right. Now, you're a wage taker, so you actually don't have to pay the people anymore. Once the technology would go through the entire industry, presumably yes, but here the technology is just for that company. I'm going to skip this problem. This is a summary table from your book. I just want to emphasize, this is what we were talking about with robots and workers. If robots and workers are substitutes in production, meaning you use one or the other, the substitution effect and the output effect are the two different things that we have to talk about as things change in price, right? Are they substitutes? Are they complements? Do they increase output or not, right? This is a table that you can study, but I'm going to describe it in a different way for you. Let's talk about labor and capital. The substitution effect, in my own words, the firm is going to purchase more of the relatively less expensive unit. So if you could substitute, let's think of a simple example. If you could substitute checkout, what's the name for this? Automated checkout at a store, you could pay a cashier to be there or a machine. If the machine is less expensive, you are going to substitute over to the machine. The output effect might mean you are having so many more people come through and check out that you actually need more people. Remember, there's one person still overseeing the 4 different output kiosk checkouts at a place like Home Depot. Well, you may actually end up with more demand for all inputs if the output effect is even larger than the substitution effect. You're going to substitute to the cheaper thing, but what if your output goes up so much that you need more labor and capital? That's what this is saying here, okay? Complements, you need them together, right? So Bobcat operators need a driver. When the price of a Bobcat decreases and labor is complementary, there's an increased demand for labor. So as this is the one is saying, is capital, as the price of capital price would go down, your demand for labor might actually go up for people to work the capital. So this is, again, when the things are needed together. A summary slide that talks about this is on the next, and we'll come back to that in a second. But this is also for your book. I think it's very helpful. It starts with demand for labor will increase when? Demand for the product increases. The productivity of the labor increases. The price of a substitute input decreases provided the output effect exceeds the substitution effect. So capital gets cheaper in the checkout line, but you're producing so much more that the substitution effect wins. Well, then you'd need more labor. That's this one. Next one, the price of a substitute input increases. Those machines get really expensive provided the substitution effect exceeds the output effect. Now the substitution effect is bigger and the capital got more expensive. She would actually demand more labor, right, to substitute back because the output effect is less than the substitution effect. And the last one is like the Bobcat operator. The price of a complementary input increases, so that it's capital getting cheaper. You would actually demand more labor as a result of the capital getting cheaper. Okay? And I actually skipped this. I want to go back. This is an article from The Economist magazine a few years ago. It tells the story of Alumotion. Rather than firing workers, Alumotion's clients often end up adding shifts because production costs drop. And this is because they have more robots. Going back up a little, workers fear being replaced by robots. So as salespeople carry demonstration units in unmarked cases and initially only meet a potential client's senior management behind closed doors, right? Later you can see workers generally warm up to collaborative robots quickly. So will robots take all our jobs? It actually, most economists are very optimistic about this. They would say productivity goes up for everybody. There's going to be tons more work to do. We're never going to run out of work and problems to solve. The robots will simply help us. So if you want to read more about this, friend or foe, you can read this article, Our Friends Electric, on The Economist magazine's website. Elasticity of demand, exactly the same as before. Percent change quantity demanded over percent change in the price, right? As the wage that you have to pay changes, how much does the resource demand change? The determinants, shift a curve, elasticity measures a movement, and the rules are the same. If it's greater than 1, it's elastic. If it's less than 1, it's inelastic. If it's equal to 1, it's unit elastic. And there are different resources that have different elasticity, like how quickly can you hire more barbers? How quickly can you hire a lawyer? Time is a factor in these, but also the change in the price and the quantity demanded. This is what I was alluding to also from the book. How substitutable are the resources? How elastic is the demand for the product? If it's really inelastic demand for the product, it's going to be really inelastic demand for the resources. And the proportion of cost that the resource represents, right? If your labor is your massive cost, and like say they're 80% of the cost of your product and they demand a 50% increase, well, you would presume that it will be more elastic. The higher the proportion of the cost, the more elastic. The more substitutes, the more elastic. The fewer substitutes, the more inelastic. The smaller the proportion of the cost. Like imagine you have plastics as part of your cost and it's only 2% and it doubles to 4%. Well, that's percentage-wise a big increase, 2 to 4. But the overall percent of your company's cost is very small, so it'll tend to be inelastic. So those are the determinants of elasticity demand. Last thing, we're almost done. The utility maximizing rule was when we learned that you're going to spend money on things until each dollar is doing the same work. Okay? Your marginal utility on A over the price of A equals the marginal utility of B over the price of B. This is like coffee or cider and donuts. How much are you going to buy of each? Well, now we're doing the same thing with labor and capital, and this is the equation you want to follow. Does it look familiar? Right? Now we're saying, just like here was marginal utility in Unit 2, now in Unit 4, the rule is, for a given input, you want the last dollar spent to yield the same marginal productivity. So the marginal product of labor over the price of labor equals the marginal product of capital over the price of capital. If per dollar capital is more productive, hire more of it until it equals the productivity of the dollar spent on labor, or vice versa. This is not the same as the profit maximizing rule. Notice the change. Before it was marginal product of labor over the price of labor equals the marginal product of capital over the price of capital. Now it's the marginal revenue product of labor over the price of labor, and the marginal revenue product of capital over the price of capital. You don't only want to go to where the per dollar is doing the same work, but to where it's equal to the price of them. Right? So you could be at a least cost combination where something like this, right? You'd say 5 equals 5 for a least cost combination. Here you want to go all the way to where they're equal to 1. So this would be an instance where you'd say, if the marginal revenue product of labor is $10 and their price is 8, well, what should you keep doing? Because of diminishing returns, hire them to the point where it's $8. And say your capital, the marginal revenue produced is $25 and the price of capital is 20. What should you do? Keep hiring them until, because of diminishing returns, 8 over 8 equals 20 over 20 equals 1. So it's a problem I just made up right now. We're going to do more practice with this in class next time.